Alright, let's make this simple. When people hear the word networking, they usually imagine cables, routers, Wi Fi problems, and maybe some scary technical words like IP addresses, packets, servers, the internet. But networking is not as scary as it sounds. Actually, networking is one simple idea: devices talking to each other. That's it. Your phone talks to YouTube. Your laptop talks to a website. Your console talks to an online game. Your printer talks to your computer. So today we are going to demystify networking. No scary wires, no boring definitions, just the simple story of how device communicates. So what is a network? A network is a group of devices, and these devices are connected, so they can share information. Think about your home. You might have a laptop, a phone, a printer, a smart TV, and maybe a game console. All these devices can be part of a network. They connect, they send messages, they share information. That's the big idea. Network is not magic. It is not just cable. It is a way for devices to talk. Here is the key idea. Networking is about communication. One device sends a message, another device receives it. That's it. Think about texting a friend. You write a message, you press send, your friend receives it. A computer network works in a similar way. But instead of people talking, devices are talking. Your phone says, "Can I open this website?" The server says, "Yes, here is the page." So remember, networking is not really about cables, it is about communication. Now let's have an example. Think of a network like a city. In a city, you have buildings, you have addresses, you have roads, you have signs, and you also have delivery boxes. A network works in a similar way. Devices are the buildings. Each device needs an address. That address is called IP address. Packets are like delivery boxes. They carry information. Routers are like road signs. They help those boxes move in the right direction. So in a city, roads move people and packages. In a network, connections move data. Same idea, different world. Most of the internet works like a conversation. One side asks, the other side answers. Your device is usually the client. The client asks for something. Maybe a video, maybe a website, maybe a file, maybe a message. The server is the computer that responds. It stores the thing you asked for, and then it sends it back. So imagine this. Your phone says, "Can I have this YouTube video?" The server says, "Sure, here it is." That's the client and the server. The client asks. The server responds. Simple. Now here is the interesting part. When you open a website, your device does not jump straight to the server. It doesn't magically appear there. The message travels step by step. First, your device creates the request. Then, your router sends it out. Then the internet guides it. And finally, the request reaches the server. Then the server sends data back. So the journey looks like this: you, router, internet, server, and then back again. It feels instant, but behind the scene, many small steps are happening. So now we need to add one important word: IP address. An IP address is like a home address, but for a device. Why does that matter? Because data needs to know where to go. Imagine ordering a package. If the delivery driver has no address, where should the package go? Nowhere. The same thing happens in a network. If your device asks for a data, the data needs a return address. So the IP address helps with two things: where should the data go, and where should it come back? That's the job of an IP address. It's the device's address on the network. Now let's talk about packets. This word sounds technical, but the idea is simple. Data is often too big to send as a giant file. Think about a big book. Would you send the whole book as a one huge page? No. You could split it into pages and then send the pages separately. That's what networks do. They split data into small pieces. Those pieces are called packets. Each packet travels across the network. Then the receiver puts them back together. So packets are small chunks of data. They make big messages easier to move. Let's make this even more clear. Imagine watching a video. The video is not sent as a one giant block. That would be difficult to move. Instead, the video is split into packets. Packet 1, packet 2, packet 3, and many more. These packets travel to your device. Then your device rebuilds the video. That's why the video appears to your screen. So when you watch YouTube, you are receiving many small pieces. Your device puts them together, and then you see one smooth video. Pretty cool, right? Now, what does a router do? A router helps data move between networks. Think about the city example again. If packets are delivery boxes, the router is like a traffic guide. It looks at where the packet needs to go. Then it sends it in the right direction. At home, your router connects your local network to the internet. Your phone talks to the router. Your laptop talks to the router. Then the router sends data outside and brings data back in. So the router is not just a Wi-Fi box, it's a guide for the network traffic. Now let's compare that with a switch. A switch connects devices inside the same local network. Think about a school. Computers in one classroom may need to talk to each other. A switch helps them to do that. It keeps local communication organized. So here is the difference. A switch connects devices inside one network. A router connects different networks together. That's the key difference. Switch equals local connector. Router equals network connector. One works inside. The other helps you go outside. Now let's talk about Wi-Fi and Ethernet. Both connect devices to a network, but they do it differently. Wi-Fi uses radio signals, no cables. You can move around, you can sit on your couch, you can use your phone anywhere nearby. Ethernet uses a cable. It is wired, but it's usually more stable and often faster. So Wi-Fi gives you freedom. Ethernet gives you stability. Which one is better? It depends. For a phone, Wi-Fi is perfect. For gaming, streaming, or work on a computer, Ethernet can be better. Use the one that fits the situation. Now here is something important. The internet is not one giant computer. That's a common mistake. The internet is a network of networks. Millions of smaller networks connected together. Your home network connects to your provider. Your provider connects to other networks. Those networks connect to even more networks, and together they form the internet. So when you open a website, your data may travel through many networks. It feels like one thing, but really, it's many networks working together. That's why we say the internet is a network of networks. Now let's put everything together. What happens when you open YouTube? First, you type YouTube, or you tap the YouTube app on your phone. Your device sends a request. It says, I want this video. The request travels through your router, then through the internet, then it reaches YouTube's servers. The server responds, but it doesn't send the video as one giant thing. It sends packets. Those packets travel back to your device, and then your device rebuilds them. Then the video plays. So when you watch a video, many things are happening. Requests, servers, packets, routers, addresses. But the idea is simple. Your device asks, the server answers. Now, because the networks move data, they need protection. Why? Because data can be private. Messages, passwords, photos, bank information, school accounts, game accounts, and all of this data needs to be safer. That's why we use security. A password proves you are allowed in. Encryption scrambles data, so other people cannot easily read it. A firewall blocks unwanted traffic. Think of it like a house. The password is the key. Encryption is a secret code. The firewall is the front gate. Without security, data can be exposed. So networking is not only about sending data. It's also about protecting it. Now let's do a quick activity. Try to explain networking using only these words. Device sends, packets through routers to another device. So we can make a sentence like this. A device sends packets through routers to another device. That's networking. Simple. One device wants to communicate. The message is split into packets. Routers guide those packets. Another device receives them. And that's the whole story. You don't need complicated words to understand the main idea. Let's recap. A network is devices communicating. An IP address is a device address. Packets are small pieces of data. A router is a traffic guide. A switch is a local connector. And the internet is a network of networks. That's a lot of words, but they all connect to one idea. Device needs to talk clearly. They need addresses, they need path, they need guides. They need small piece of data that can move easily. Once you understand that, networking becomes much less scary. So that's networking. Every message you send uses networking. Every website you open uses networking. Every video you watch uses networking. Every online game you play uses networking. But behind all of that, there is one simple idea: devices talking clearly. Networking is not magic, it's communicating. Small messages moving step by step from one device to another. Once you see it that way, the internet feels a lot less mysterious.